Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 050. The purpose of this video is to show students how to graph linear equations using slope-intercept form, and also how to write linear equations given lots of different types of information, whether that be given slope and y-intercept or just 2 points on the line. We'll go through a variety of examples here. Let's begin with how to graph linear equations having an equation in slope-intercept form. So I've got two equations here. Actually, let's start with this one here on the left. Y equals negative 4x minus 1. Notice that equation is in slope-intercept form, which means that it's solved for y. This is nice because it allows me to identify the slope, which is the coefficient in front of the x term. So the slope is negative 4. And the y-intercept, which is the constant term beside the x term in that equation. In this case, the y-intercept is negative 1. So if I have those two pieces of information, then I can graph the line. Let's start by finding the y-intercept on the y-axis. So think about this y-intercept as the starting point for graphing the line. That y-intercept tells me where the line crosses the y-axis, so I know the line crosses the y-axis at negative 1, so I'm going to plot a point there. And that's going to be our starting point for graphing. Then I use the slope to determine where the next point on the line is. Now, remember that I can write negative 4 as a fraction, negative 4 over 1. And that tells me the rise and the run. Okay, so what I recommend students do is start with the rise. So I know from the y-intercept, the point that I just plotted, I'm going to rise up 4. So 1, 2, 3, 4. If I go up 4 units, that puts me at positive 3 on the y-axis. Then I look at the run. So in this case, the run is 1. And I know that my slope is negative. And I know that if my slope is negative, my line needs to be moving downward as I go left to right, something like this. So we need to run to the left to make that happen. And what's nice here is that if I'm on the y-axis, look what is to the left of the y-axis. Those are the negative values on the x-axis. So negative slope means I want to go towards those negative values on the x-axis. So let me zoom in a little bit here. That was a little too much. Okay, so I went up 4. And then I'm going to go left 1. I'm going to run towards those negative numbers since I have negative slope, and that gives me another point on the line. So that's one way I could find the next point. Another option is from this y-intercept, I could have went down 4 points. 1, 2, 3, 4. Well, move up a little bit. 1, 2, 3, 4, and then over to the right 1, and notice that puts me on that same line. So either way you want to do it is fine. As long as I end up on that same line, it's okay. I just think it's easier when students are first learning this to, first step is to plot the y-intercept and then rise up, because obviously rise means, most people think of rise as going up. But that's the definition there. So you rise, meaning go up the y-axis, and then the run, basically you use the sign of the slope to determine which way you run. If it's a negative slope, I'm going to run to the left, which is towards these negative numbers. And I have negative slope, so those things kind of go together. If it was a positive slope, I would want to run to the right, because that would be running towards these positive integers. Positive slope, those two things go together. We'll do a positive slope in this next example. Okay. So I technically only need 2 points to make a line. I just did a third point just to give you another option for getting another point on that line. And so once I get those points, I can graph the line, and there we go. So why slope-intercept form really makes it nice for graphing. I don't have to make a whole table of ordered pairs. I don't have to find intercepts. So it is really, really helpful way of graphing. So I would encourage you guys to use that to graph lines if possible. All right. So here's another example. Y equals 2/3 x plus 5. So once again, this is already in slope-intercept form. I've got my slope, which is 2/3. I've got my y-intercept, which is 5. So first things first, start by plotting the y-intercept, which is on the y-axis here. So I'm going to plot that point. All right, then I'm going to use my slope to get the next point, and my slope is 2/3. It's already as a fraction, so that's nice. So just think about the numerator as being the rise, the denominator as being the run. So then from the y-intercept, I'm going to rise up 2, and then I'm going to run 3 in the positive direction. Notice if I have positive slope, my line needs to be going upward from left to right, so like this. So I'm going to run to the right, which means I'm going to run towards the positive values on the x-axis. So that's a helpful way to remember that. So go up 2. I'm going to zoom in here. So I'm going to go up 2. Then I'm going to run to the right 3. And that's going to put me here on that line. Right. Like I said before, another way I could have done this, I could have went down 2 and then left 3. That puts me on the same line. Right. Either way, I think it's more intuitive for students when they're first learning this to rise up and then run to the left if it's negative slope towards those negative values on the x-axis, or run right if it's positive slope, running towards the positive values on the x-axis. And so once I have my points, I can graph my line. And like I said, using slope-intercept form makes graphing lines a lot easier. It's a lot easier than making a table. In a lot of cases, it's easier than doing intercepts. All right, let's do an example here that's slightly different. So let's say I want to graph (4x minus 7y equals negative 14). Alright, notice this equation's not in slope-intercept form. Alright, so if I want to graph it using slope-intercept form, first thing I got to do is solve this for y. Putting it in slope-intercept form, and we worked on this in the last section. So I would want to subtract the 4x to bring it to the other side. Obviously negative 14 and negative 4x are not like terms, so I'm not going to combine those. So that's going to give me negative 7y equals negative 4x minus 14. And then I'm going to divide everything by negative 7. And so that's going to give me an equation of y equals, and obviously negative 7 is not going to go into negative 4, so that's going to remain a fraction, and a negative divided by a negative is a positive, so 4/7 x, and then negative 7 into negative 14 is a positive 2. So the equation in slope-intercept form would be y equals 4/7 x plus 2. Now I've got my slope, I've got my y-intercept. So now I can graph start at 2, which is the y-intercept, and I'm going to go up 4 because that's the numerator of my slope, so that's the rise. 1, 2, 3, 4, and then I'm going to go over 7. 1, 2, 3, 4, 5, 6, and I ran out of tick marks. 7, so up 4, 2, 3, 4, and to the right 7 since it's positive slope. All right, and then that should give me enough points to make a line. All right. So once again, graphing, we just had to do a little bit of extra work there to actually get that equation in a slope-intercept first. All right, so that's how we can graph linear equations using slope-intercept form. Let's look at writing some linear equations. So I've got a variety of examples here for you guys. The first one, let me zoom out a little bit. It's actually pretty easy. It says write an equation of the line with given slope and y-intercept. Well, and they give us the slope and they give us this y-intercept. Well, that makes it pretty nice. Here's my slope-intercept form. Y equals mx plus b. So if I know m and I know b, I can substitute those values in and have the equation written. Remember, x and y is going to stay x and y. Those represent the points that are on the line. All right, so that is in slope-intercept form. In certain cases, you know, a textbook or a math teacher may want you to write this equation in standard form. And it's pretty easy to write an equation in standard form. You basically just move the x and y to the left side of the equation, so they're both on the left side of the equation. So to do that, I just want to do the inverse here. So since that's a positive 5x, I'm going to subtract the 5x. And so when I do that, obviously negative 5x and y are not going to combine. So I want to write the x term first, the y term second, and then it equals 3. And this is what we call standard form. And in certain cases, you know, certain textbooks like to have this leading coefficient to be positive. I don't think our textbook really cares about that. You know, if we wanted to make this leading coefficient positive, so instead of having a negative 5, having a positive 5, I could basically just multiply everything by negative 1. And that keeps my equation balanced and would then have this leading coefficient positive. Like I said, I don't think you're going to have to worry about that with this textbook. Okay. All right. Another type of example here. Is writing an equation of a line giving the slope and a point on the line. Okay, so I have a point that's on the line and I have the slope. So to do this, we want to utilize a equation called point slope, and it is in this form: y minus y1 equals m times x minus x1. This is what we call point slope, and it is composed of a point, and slope. Okay, so the point is the x1, y1. Alright, so this is a comma right here. So that's an ordered pair, which is a point on the line. So this x1 represents the x-coordinate of that point on the line. The y1 represents the y-coordinate of that point on the line. And the m is, of course, the slope. So if I have those pieces of information, then I can then use point slope to write a linear equation. So I actually do have a point, and I have the slope. I'm going to label the x-coordinate as x1 and the y-coordinate as y1 just to keep myself organized. So I'm going to substitute y1 into this form, point slope form. I'm going to substitute the value of m in here, and I'm also going to substitute the x-coordinate. And you've got to be careful of signs here. All right, I have a subtraction, and then I'm plugging in a negative. So those double negatives are going to then turn to positives. Okay. And then from here, I would want to do some simplifying and rearranging of terms to put this into slope-intercept form. So I would want to distribute the negative 2. So negative 2 times x is negative 2x, and negative 2 times 11 is negative 22. And then from here, if I want to put it in slope-intercept form, I want to solve it for y. So I'm going to subtract 12 from both sides. Of course, these 12s cancel. And then negative 22 minus 12 is going to give me negative 34. Okay. And so now we have that equation in slope-intercept form. Okay. And depending on what the textbook wants, they may want this in standard form. If that's the case, we just need to bring this x term over to the other side by doing the inverse. So since that's a minus 2x, we will add 2x to both sides. And so we get this. So I think it's easier, when you're writing these linear equations, to go from point slope, right, to slope intercept. So point slope to slope intercept, and then go to standard form. I think it's just a natural progression there. Once you get it in slope intercept form, the last step is just do the inverse and move that x term over to the left. Okay. All right. And last but not least, writing an equation of a line passing through a pair of points. So I know that both of these points are on the linear equation that I'm trying to write. They're on the graph of that linear equation, and I want to figure out what the equation of that line is. So if you haven't discovered, the common theme here is that finding slope and y-intercept is important for me to write a linear equation. So let's find slope. All right. We learned how to find the slope between 2 points in the previous section. So I'm going to do that. I'm going to label these ordered pairs, x1, y1, x coordinate of the first point, y coordinate of the first point, x2, y2, x coordinate of the second point, y coordinate of the second point. And then remember that my slope formula is y2 minus y1 over x2 minus x1, right? And so that's how I can find the slope between 2 points. So now I have my ordered pairs labeled, so let's substitute those numbers in. So -5 minus 3 on the top, -2 minus -1 on the bottom. So that gives me -8 on top. And of course these double negatives turn to a positive. -1 on the bottom. And of course -8 divided by -1 is a +8. So that gives us the slope. And now I have the slope and I have 2 points on the line. I really just need to use one of those points to write my equation, because remember that my point slope formula just requires me to have the slope and 1 point on the line, and I have that now. Alright, so if you want to be consistent, you already have these labeled x1, y1. You could just, use that same point. Okay, so y1 is going to be the y coordinate of that ordered pair. M is the slope I just found. x1 is the x coordinate of that point. Be careful with your signs. Those double negatives are going to turn to a positive. So now distribute the 8 through the parentheses. So I get 8x plus 8. And then let's go ahead and put that in slope-intercept form. So solve it for y. So I'm going to add 3 to both sides. And so now this is in slope-intercept form. Alright. And then, like I said, if we want to put this in standard, I would just move this x term to the other side, doing the inverse. So since that's a positive 8x, let's subtract it. So we get this in standard form. So once again, we're following that natural progression. So just a recap here. First thing we did is we found the slope between those 2 points using the slope formula. Then I used my point slope form with the slope I just found and one of those points. It doesn't really matter which one I use. I could use either. And just to be consistent, I stuck with the first one since I already had it labeled x1, y1. So plugged in that slope, those coordinates for that ordered pair, simplified, put that into slope-intercept form, and then move the x term to the left-hand side to put it in a standard. Alright. So hopefully those examples give you some resources so that you can then become proficient and be able to work through the homework. So if you have any questions, as always, please email or come by the office. Thank you.